So, welcome you students for our quick completion of adsorption part today in this session. Can you see what these are? Or do you love to eat them? Congratulations, I too also love. Now, if you keep them in air for 4 hours, would you like to eat them? Nah. Why? They lose their taste. Again, why? Because they absorb moisture. You know, this is a common thing when a chemistry class is boring, you require. But you know how it works? It again works by absorption. It can pass through the skin and starts working. And this is what you require in winters. You know how it works? It works through adsorption, mind you. See this dynamic lady, unfortunate lady, she died because dimethyl mercury could adsorb and absorb into her body when it has spilled accidentally onto her system when she was doing a research project. So accidents do happen, but one should be extraordinarily careful in chemistry labs. Now we quickly look at the chemical adsorption or chemisorption involve what is called as the valency forces, that is the adsorbing gas and adsorbent will have a kind of chemical bond, whereas the physisorption or physical adsorption involve only van der Waals attraction between the gas molecules or solute particles and the adsorbent. You know, the adsorption can happen between a solid surface and a gas, and also between solid surface and a solute of a solution. Now, if you look at physisorption, it is lacking specificity. Any damp gas can have physical adsorption with any damp surface. And if you want chemical adsorption, it is something very specific. For example, iron only can act as catalyst for Haber process. Because I am a rich person, I will buy gold, I will try to make ammonia using gold, means no, it won't work that way, because gold cannot chemically adsorb hydrogen and nitrogen to give ammonia. So, the physical adsorption is not specific like Dewar flask, noble gas separation and all, whereas chemical adsorption is specific. Nature of adsorbate, this is to be understood very clearly. For physical adsorption, the gas which can be easily liquefied readily undergo adsorption, whereas for chemical adsorption, this is more the gases which can react with a particular metal can undergo chemical adsorption. So, the liquefiability is not an issue for chemical adsorption, but it is an issue for physical adsorption. And this gas which is adsorbed once can also come back happily in case of physical adsorption, because reaction is always reversible, and that obeys of course Hartley principle. If you increase the pressure, more gas gets adsorbed. Whereas in chemical adsorption, it is irreversible. If you see nitrogen and hydrogen are adsorbing on the surface of iron catalyst, again they won't come back as it is, they become ammonia and come out. So it is irreversible. Surface area of adsorbent is equally important for both. More is the surface area, more is the extent of adsorption, whether it is physical or chemical. And when this adsorption is happening, the heat energy released is less. It is maximum up to 40 kilojoules per mole in the case of physical adsorption, whereas in chemical adsorption it can be 8 times more, that is about 240 kilojoules per mole. And this comparative account one can see, physical adsorption, van der Waals, that one is covalent or valence forces. Specific is chemical, not specific is physical. Depends on the reversibility in nature. It depends on the nature of the gas liquefiability for physical. Enthalpy of adsorption is low, whereas in that case it is more. The low temperature is favorable for physical adsorption. But chemical adsorption, if you raise the temperature, many more molecules get energy of activation, and the extent of adsorption, at least to some extent, increases in chemical adsorption. And in physical adsorption, as you know, that activation energy is almost negligible, whereas definitely there is appreciable activation energy in chemical adsorption. And both are affected by surface area. Most importantly, physical adsorption is of multi-layer, multi-molecular layer on the surface of adsorbent, whereas chemical adsorption is unimolecular layered. Now an isotherm is essentially a graph plotted for the amount of gas x by m adsorbed. X is the mass of gas adsorbed, m is the mass of the adsorbent you take. X by m versus pressure graph for physical adsorption definitely follows this pattern. At lower temperature the amount of gas adsorbed will be more rather than at high temperature. Mind you that this relationship between the amount of gas actually adsorbed and pressure was given by a scientist called Fraundlisch. It is called Fraundlisch adsorption isotherm. Isotherm because each line is plotted at a particular temperature. Keeping the temperature constant, you are studying the variation of amount of gas adsorbed with pressure. Hence it is isotherm. The relation is x by m is equal to kp to the power 1 by n. It means x by m is directly proportional to nth root of pressure. If you carefully observe, at lower pressures, the n value appears to be 1. It is a almost linear relationship. At moderate pressures, n value is anything between 2 to 10. Whereas at very high pressures, n value appears to be infinity. It means the amount of gas adsorbed is not dependent on pressure. Anyway, if you take logarithms to this, it can be like log x by m is equal to log k plus 1 by n log p. It is looking like y is equal to mx plus c. Y is equal to mx plus c. Here x is log p, m is 1 by n, y is equal to mx plus c, c is log k. This graph is naturally a straight line which will never pass to the origin. The intercept is nothing but log k. Slope of the graph is, as you know, 1 by n. Now the Fraundlisch adsorption isotherm is applicable with the limited scope for physical adsorption, and there are better interpretations have come, but we consider only Fraundlisch adsorption isotherm. Mind you that for many gases 1 by n can be 0. If 1 by n is 0, it means what? N is infinity, pressure is very high. 1 by n can be 1, where n is equal to 1, the pressure is low. So the n value keeps on changing depending on the pressure situation. Notice that the adsorption from solution phase is also possible. You can take, for example, acetic acid in a solution, maybe 0.01 molar, 0.1 molar, 0.001 molar, so on. Add a little bit activated charcoal, shake it for 10-15 minutes and take out the charcoal and dissolve all the acetic acid adsorbed. See how much amount of acetic acid adsorbed in each case. You will notice that the amount of acetic acid adsorbed depends on the concentration. Therefore, one can work out a relation like x by m is equal to kc to the power 1 by n, where x by m is amount of the acetic acid adsorbed or any solute for that matter adsorbed, c is its concentration. It follows the same pattern. Mind you that if you plot a graph for the amount of gas adsorbed and temperature, it is called as adsorption isobar. And now the application of adsorption we have seen earlier. There are many applications: gas mass, controlling humidity, coloring matter, catalysis, separation of inert gases. In curing diseases and using drugs also, this idea of adsorption is utilized. So many moon, so many Jandu bombs, so many things have been worked out based on the principles. And some indicators have been developed based on the principle of adsorption, especially silver halides will adsorb coloring agents like eosin, fluorescein. Chromatography is a very important technique in organic chemistry in separating different components that requires a stationary phase and a mobile phase. About chromatography we talk in another video. At the moment, this is all about adsorption, a quick review, and also if there is time we will see one small problem. The problem is of some interest. Quickly see this. 2 grams of activated charcoal, a gas adsorbed by 0.1 gram and 0.8 grams at 10 torrs pressure and 80 torrs pressure. Calculate the n value for Fraundlisch adsorption isotherm. So now this can be solved like, for any gas that is obeying Fraundlisch adsorption isotherm, x by m is equal to kp to the power 1 by n, and m is same in both the cases. So x1 by x2, that is 0.1 by 0.2 is equal to p1 by p2. If you simplify, you can see that n is equal to 3. This type of problems can be asked. I hope you understood what is adsorption. Thank you.